Hello, biology students and biology support personnel. This is Mr. Brennan. I just want to give you a little rundown of how to use this diffusion simulator. Some folks may have been absent in class or for whatever reason didn't get the first introductory lesson about it. So I just want to walk through this. This is a box here with a divider and a chance to add particles, blue particles on one side and red particles on the other side. Okay. And you can adjust the mass of the particles. You can adjust the radius of the particles. Let me show you how the blue ones can get really small. Okay. And you can change the temperature of the particles. Um, and it's worth noting, like, let's notice what happens when we make the red ones really cold. They're pretty slow. And if we make the blue ones pretty hot, they're faster. And that's a really important piece, okay? I'm going to remove the divider and allow them to kind of interact, and you can see that they start invading one another's spaces. This is about diffusion. It's about the ways in which molecules will start to bounce around and collide with one another and eventually get to a point of like kind of what we might call equilibrium, where they're kind of equally distributed throughout the whole box, okay? But let me stop there because there's a lot you could do. I just want you to see, like, what controls you have and what you can do. But there are some other things to do. In particular, there's a thing we would want to do, which is maybe to record the rate of diffusion. So I want to show you how to set that up so you can record the rate of diffusion really well. This so that we just have the blue particles, okay? It doesn't matter which color it is, but just one kind of particle. And I want to select a box here called the center of mass, and then I'll also want to turn on a stopwatch, okay? And notice that the little blue bar here is kind of, meandering back and forth around the middle of the box, which is what we would expect, right? The center of mass, this bar, kind of tells us the average position left to right of all the particles. So it should be about in the middle because they're kind of well distributed. But there's still the occasional drift to the left or drift to the right, okay? Now, if we would like to measure the rate of diffusion under a variety of conditions, we need a standard way of capturing that data, okay? And I want to show you the way to do it, okay? So step one is to turn on the center of mass and the stopwatch, okay? And then step two would be to pause the animation, okay? So we'll just pause it so we can do a number of things and be ready once we start the animation again, we'd be ready to like track the diffusion, okay? So I want to do a couple of things. Now that it's paused, I want to quote unquote start the stopwatch, but you see it's not counting up time because the whole animation is paused. But once we go live, that counter will start counting, and it'll be counting in picoseconds, which is a very tiny fraction of a second. But we can just call it time, okay, and that'll be an indicator of time, okay. I can also remove the divider, and now you see a dotted line where the divider was, and we're basically ready to go because if we hit start over here, the blue particles will start to diffuse from an area of high concentration to the area of low concentration. And we'd be able to track how much time it takes to do that, okay? So let's start the animation, and then I'll pause it one more time. Here we go. We're going to start it up. We're going to watch. Now they're drifting this way. Notice the blue bar is drifting forward, okay? And now we're getting close to a critical moment. I'm going to pause it, okay? And here, the bar is almost in the middle of the entire box, the large box. Once it gets there, once it gets to that point, we could call time and say, okay, it took that much time under these conditions, this mass, this number of particles, this radius, this temperature, those conditions, it took so much time, it's going to be a little bit more than 21 picoseconds to diffuse to get to that point where it was evenly balanced across the two boxes. And now that I'm close, if you want, you can actually creep up on it with this little single frame movement here, okay? And just keep hitting that until you get the blue bar to be centered, okay? And we can stop and say, okay, under these conditions, all right, it took 26 point, let's call it 5 picoseconds, okay? That, once we have that data point, okay, we can reset the entire animation, okay? We can call things up again, center of mass, stopwatch. We can call back the number of particles we had. I can't remember how many particles it was, but let's just say we were playing around with particles. We would leave the mass the same, the radius the same, and the initial temperature the same. And we go through the same process of setting this up for capturing the rate of diffusion by pausing the animation and setting us up for success after that, okay? One could change the number of particles and keep other things constant. One could change the temperature and keep other things constant, okay? So as you explore the rate of diffusion, I guess my overall advice would be probably use one particle at a time and just play around with one of the traits of that particle, okay? I hope this was helpful for all of you, and good luck.